Right, so let's start with the integers. We have here XYZ integers set up, and I have a list of examples with their variables named conveniently to show you what kind of example it is for the various operations we can do with our integers. So let's have a look and visualize. So setting up XYZ, nothing new. We have XYZ in our global frames. And now we're going to start looking at what happens with each of the sections. So if you have a minus section, that's a negative. So the negative example, it just becomes a -3, just as you expect. Sum works in the same way. Y plus x is 13, 4 plus 9. Difference, also the same thing. You'll notice how if there is a negative in front, it's because order does matter, and order will change the way it computes. We then have multiply and exponent examples. So those previous were using the plus and minus sign. Now we're going to use the multiply sign. We have the multiply and the double multiply. So the single multiply, which is right here, multiply example, is just 4 times 3, or y times z. The double multiply will be 64, which is 4 to the power of 3, and that is 64. So the double stars means to take it to the power of. The star and the double star is above the 8, so that's where you can find the multiplication sign. This triple O stands for order of operation. So order of operation does matter. So what should happen is y times z should be first, then x minus x. We know y times z from the multiply example is 12. We know x is 9, so it should be 9 minus 12. In other words, -3. And we do have -3. If we flip it around, if we have 9 minus y, which is -4, times 3, that is 9 minus y is, so y is -4 now, so it's +5. Yes, +5. +5 times 3 is +15. And we have +15 for order of operations. So brackets are used just like mathematics in determining order of operations. Now we move on to divide. Divide has two examples. The first is dividing where the number is divisible by the denominator. So x is 9 and z is 3. 9 is divisible by 3, but no matter what, it'll always become a float. You notice the float is anything with a decimal, so this is a float. So regardless whether it's divisible by or not divisible by, you'll always get a floating point if you divide. Division example 2 uses one that's not divisible by. So 9 is not divisible by 4, so you get 2.25, and it automatically calculates it out for you. Now, there are times when you want the integer divide. Integer divide is when you divide it by a number and you take only the quotient, so the number on top of the bus stop. When you take this, you use the code double divide. So the double divide is how you show that this should be integer divide. So x divided by y, x is 9, divided by y is 4. What should happen is when if you do the calculations, it'll be 2 with remainder 1. So because it's integer divide, it will take only number on top of the bus stop, so it'll be 2. Another way to think about it is it will round it off. It will always round down, not round up. It will always round down to the nearest integer. If you want the remainder, that's also possible. What you do is you go x and use the percent sign y. By the way, the division sign is underneath the question mark next to your right shift. The percent sign is above your 5. This is a modular arithmetic, which means you take x, you divide it by y, and you ignore the quotient, and you take the remainder. So when you take 9 divided by 4, your quotient is 2 with a remainder of 1, which means x mod y is 1. And so you have 1. And these are the tools you can use in integers to manipulate them.